Hey guys, welcome back to Rocket Gyan, my fellow space tubers, and we are back here again with another launch, and this time it will be the Firefly Alpha. I know this has been a very long delay since my last stream. I tried to stream on for the Falcon Falcon Heavy launch, but it got scrubbed unfortunately, so we'll stream that also, so no worries with that. Just stay with me. And yes, today I also have some surprise for you all guys. Hi Hitesh, hi Ritik, how are you? I hope you all are doing fine. Yeah, so I do have some surprise for you guys. I hope you like it. I was trying some things in the back end, that's why there was a delay in the I was not streaming basically. So yeah, so let me just give you that thing. Just a second. Here you go. There's me. So from now onwards, I will be streaming on cam so that you all can understand it better and see how it's all going. What are my reactions and all those things. I hope you would like it. I was just setting up all these things. That's why I was having some, I was not streaming. All right, so let's have a look at the rocket itself. This is the Alpha rocket. So this is supposed to be a PSLV competitor. Okay, this specifically, this was made because PSLV was kind of stealing the US domestic market. So because of its rideshare capability, so this came into the picture kind of, I won't say it was stealing per se, because PSLV has its own delays and all, and long paperwork and everything, but yeah, that's how it was. So this Alpha rocket came to the picture, and yes, it has already been to the orbit. So this is their fourth flight. This is how it looks like. This is how it will launch during the liftoff. So here are some specs about this rocket. So it can take around 1030 kg to the low Earth orbit, which is around 300 kilometers. Kind of similar to PSLV. It's kind of less only, but still it's okay. And the payload to sun synchronous orbit is 1630. So it is a two-stage rocket. First stage is powered by 4 Reaver engines, and for second stage is powered by 1 Lightning engine. We'll have a look at that also, so just give me a second. So the 4 Reaver engines produces a thrust of 801 kilonewtons, and ISP is around 295 second. So ISP is nothing but a this thing mileage, and this uses again RP1 and LOX as its fuel, uses T-tab as its ignition. That's why you can see the green flame when it ignites, because that T-tab has its green flame in it. Okay, so you will see that in action also live. Hi Wildflower, how are you? I hope you are all are doing great. So yeah, you just saw that in action. So yes, let me just LOX and RP1 propellant turbo bump tap off cycle. What is tap off cycle? We'll have a look at it, but before that, let's have a look at the rocket itself. So this is the rocket. Here you can see the 4 Reaver engines, which will be, here you go. These are the 4 Reaver engines, and it has a very unique perspective to it, because most of the time, like Falcon 9 and other liquid fueled rocket, they have this thing called multi-axis gimbal. But in this case, it will have a single axis gimbal. So each and every engine will be able to gimbal on only one axis. Okay, but still they are able to achieve pitch, yaw and roll control, because they have engineered it in such a way that it's able to control all those parameters with just one axis of gimbal. I'll explain you also, like if I get some time, how does that single axis gimbal work, how will it be able to control all of the planes. Let me just tell you now only. So if I stop it, so what will happen is one of these engines will be able, so let's say this and these two engines can move in in this direction, which is the x-axis. This and this these two engines can move in y direction. Okay, so let's say if it wants to pitch, so if it wants to pitch, it will move these two engines. If it wants to yaw, it will move these two engines in one direction. And if it wants to do a roll, it will again move these two engines and in this direction, so that it will be able to achieve the roll control also. So it's a single axis. It will be able to move on, each engine will be able to move only in one direction, but still it will be able to achieve its directive. So this is how it looks like. This is the first stage. Talking about the second stage, so second stage is powered by one lightning engine. Again, this is this produces a thrust of around 70.1 kilonewtons and ISP of 322 seconds. It also runs on tap off cycle, uses T-tap for its ignition. So this is also, it's not exactly the Reaver engine, it's a different one, but this has one unique feature, which is this nozzle extension, which you can see, right? It is actually cooled by the exhaust gas of the turbopump. How cool is that? So yeah, startups and their innovations will always be a thing. So there is that. Now let's yeah, so just move on to the, now let me explain you what tap off cycle means. Okay, just give me a second. Yeah, so tap off cycle is nothing but it's kind of a gas generator cycle. So here you can see in this diagram what happens. So it will be either fuel or the oxidizer which will be used. So what will happen is fuel and the oxidizer will be pumped into the combustion chamber, and some of the gas from the combustion chamber will be taken out and will be used to rotate the turbines. It's similar to gas generator cycle engine, but you can see the difference here. So and again you can see that the gas which is used for the rotation of the turbines is just discarded, which means it's an open cycle engine, not so efficient, but a very simple engine. So there you have that. So we will see this in action today, and hopefully this will make it to the orbit. Now let's have a look at some pictures. So this is the real engine pictures which you can see in front of you. Here the two engines are placed side by side. Here you can see the gas generator, I mean how it would look like once I mean not the gas generator, the exhaust nozzle. And there are certain complexities going on in the engine. I won't go deep into that. And this is the second stage engine. You might be thinking, why so small? So it's not a small engine, it's just that this is just the part of the upper engine. Let me tell you what I'm trying to say. If you'll see in this picture, it will be like this part is only displayed, not this part. So this part is actually cooled by the exhaust gas which is coming up. So kind of a unique thing which they are doing in design formalities. So this is what it is. Now let's have a look at the payload which it is taking. Yeah, so this is the payload which is from the Lockheed Martin. So this Lockheed Martin is known as ESA. Kind of ironic, right? It's known as ESA, and it's able to do ESA stands for nothing but electronically steerable antenna. So yes, it will be having electronically steerable antenna, as the name suggests. That's what it will do. It's known as Tantrum. This is just the payload, and it will be hosted on a certain satellite bus, which I'll also talk about. So this is a technology demonstrator mission, and which aims to enable Lockheed Martin to perform quicker sensor analysis, calibrations, and other things. So again, this is a space force, and those kind of things related to military, so not much of info is out there. So this will result these all things, Alpha rocket, these missions which you are seeing is all designed to fasten up the pace of the delivery to the orbit. Previously they just delivered the VICTUS mission, if I'm not wrong. They delivered it on 24-hour notice. That's it. So that was amazing, and that, yes, it was successful. So it was amazing that they were able to do that. Yeah, I was talking about, this is just the payload. This is the satellite bus in which it will be hosted. This is known as the terrain orbital nebula. Here it will be powered by gas Hall effect thrusters, which is nothing but ion thrusters, so electrically charged. So it's so that it can maintain the orbit and do all the calibrations and everything on it. It will provide the necessary power, necessary thrust if it requires to maintain the orbit. So all those things will be done by this thing. Now moving on to the next part, which is the mission profile. So I hope, yeah. So the mission profile, oopsie, wait a second. Okay. Yeah. Okay. That is better now. So yes, I was saying that this is the lift. You can see, right? So liftoff will happen on this from California, Vandenberg Space Force, California, and the ignition, you can see, will happen at T minus 2 seconds, and the final liftoff will happen at T plus 0 seconds. So this is necessary because this allows those 4 engines to come to full thrust. So there are some hold down clamps which are placed on the bottom side of this rocket, and it will just what should I say, just keep it stable. It won't let it go unless the command is received that yes, the engines have achieved the full thrust, and now it will just release those clamps and it will lift off. After that, the Mach 1 will be achieved at T plus 50 seconds. Max Q will happen at T1 plus 1 minute 7 seconds, which is nothing but, again, the actual structural test will be done in the flight, and how durable it is. And let me tell you, this is all carbon fiber rocket, so durability is something which we should need to look on to it. But yeah, since it's a carbon fiber rocket, so we don't need that much of what should I say, weight. The metal and steel is not being used extensively, so there is not that much of weight. So everything has its pros and cons. So yeah, after that we have main engine cutoff, the stage separation which will happen. Stage separation here, you can see the first stage will be separated, the second stage will ignite, then finally the fairing jettison will happen, then the second engine cutoff. So here you can see the engine will cut off, but it will again do a second stage ignition, which will happen at T plus 49 minutes. Again, the cutoff will happen after 10 seconds, and then finally the payload will deploy. So this is how it will look like. And yeah, so I hope it's clear now how it will work, how it will make it to the orbit. This is still, I'm telling you, this is still $15 million per launch. Around $15 million it takes per launch, and this is still way on the costlier side. But again, something is better than nothing. So I hope this will stay, because only right now what I have seen is there have been so many players in small sat market. This is also aiming for that small sat market, but none of them have stayed. We know what has happened to Astra. Only Rocket Lab was able to deliver it in a more frequent manner, so their launch cadence was very high. I hope Alpha is also able to do that, and then if it is able to do that, PSLV will have a tough competition, because the PSLV is having right now, the PSLV as a vehicle is very good, but the problem with PSLV is that it's delayed almost, like the paperwork is very delayed, and most of the time they have to wait for their PSLV finally to be on the pad and then finally launch. So that process is kind of hectic. Again, it's a government organization, so that's how it will function. But yeah, so yes, Frederick, I hope you are liking the graphics, and let me see if we have the stream yet. Okay, we do have something. Just a second, guys. Yeah. I hope it is visible. Okay, so there you have it, guys. The clock will be just wait for the clock to settle down.
Good morning, y'all. We are standing by for a... Wait a second. Can we get some rocket views on the stream? Do we have any views of a rocket here, please? Stand by, folks. Let's check some rocket views if we could. There we go. Now we've got ourselves a rocket show. Folks, you've joined the official live stream for Firefly Aerospace. It's Flight 4, Fly the Lightning this morning. We are doing a dedicated commercial launch for Lockheed Martin, and really quickly, NASA Spaceflight is providing live stream services for Firefly Aerospace for today's stream. I'm John Galloway with NSF. With me today this morning, I've got a friend who knows a lot more about rockets than me, Miles Gray. Dr. Miles Gray, how you doing?
I'm doing pretty well. How are you?
I'm pretty good. How did we luck out and get you on the stream this morning? You're busy with the rocket.
Yeah, so I'm the chief engineer for our other rocket, MLV.
MLV.
And so I'm not working on Alpha anymore, but I came to Firefly 5 years ago and worked a lot on Alpha, so I have kind of a lot of information about Alpha, but I'm not critical for the launch today.
Gotcha. So you're not on console and mission control, so you get to hang out with us?
Yeah, exactly.
All right. So Miles will be providing us some information about Alpha because he's worked on it himself. And we are coming up now less than an hour for launch. Appreciate everybody joining us today. You may be watching in multiple different places. You may be over on Firefly's official YouTube channel. If you are, make sure you follow along there. Ring the bell or whatever you're supposed to do. You may also be watching it on NSF stream. You may be watching it on social media X as well. Wherever you're watching, thank you so much for joining us. This morning, we have just a 16-minute window remaining, I think, right? I think we were down to 16 minutes starting at, where was our T0? We're talking about Vandenberg here. All right. I believe our T0 is coming up in less than an hour, coming up on 56 minutes now. There we go. And we're looking at Slick 2 over here at Vandenberg. There's the zoom in coming down the coast. Anything informational about here at Slick 2?
So Slick 2, it's our pad. We're kind of near the beach, a little bit more inland than some of the other pads. Just down the way is Shark Beach.
Shark Beach. Are there actually sharks there?
There is a bunch of sharks there. It is the largest breeding and feeding site for great whites.
Largest breeding and breeding site for great whites.
Not a lot of swimming.
Not a lot of swimming there. So more focusing on the rocket, working on the rocket than going down and hanging out at the beach.
Yes.
All right. Hey, folks, some other housekeeping real quick. Today, at the request of the customer, we are going to remove the live views of the vehicle after SECO 1. So we'll tell you a little bit more about SECO 1 and the mission operations that are going to happen. But intentionally, those feeds will be cut after SECO 1. It's got a long coast phase in there. We're not going to stay around for the entire coast phase. Just want y'all to know if we turn off those feeds, that is an intentional thing. So we got past the Shark Beach part, I guess. Since we're doing the live stream here, also, if you've got questions for us, you can tag us in chat on whatever channel you're watching at Firefly Space if you're on Firefly's YouTube channel, and at NASA Spaceflight if you're on NASA Spaceflight's YouTube channel. So we've been going a little while here, and the teams have already been working on the rocket this morning, haven't they?
That's right. You can see on the camera there's not actually anybody out there now because we already went through pad clear. That happened at T-minus 4 hours and 30 minutes. So everybody's gone. That group is called Red Team. They kind of, their whole job is pulling off all the RBF tags.
Okay.
They're turning the last valves they need to get
So
propellant on
yeah,
board.
now
They're
everything
basically
is
just kind
ready.
of
I should be able
walking up
to
as they,
talk to you guys. So
retrieve
yes,
the pad.
Blues Travel, thank you so much for that.
So that happened at 4 hours and 30 minutes. We started kind of the rocket kind of comes alive. From my perspective, at least, I'm kind of a fluids guy, but
It starts to breathe.
yeah, it starts to breathe at T-minus 6 hours. We start loading helium. So our system has like a circulation loop rather than just filling helium into the LOX tanks.
Right.
So we start at T-minus 6 hours. We start chilling and filling. So we're increasing pressure as we're going down
There
in
you
temperature.
go. So it's
and
a
then an
full
hour later.
black rocket, but right now you can see it's kind of grayish white, and obviously we know why that is the case, right? So yeah, let's see.
Risky if they mix and
Right. That's sort of how the rocket works in the first place.
Exactly.
Yeah.
So we loaded basically all the fuel at T-minus 5 hours. So it's completely full of fuel. And then immediately after pad clear, we can start loading locks. So we also have almost all of the locks on board that we're going to have.
Gotcha.
You can actually see on the stream there's this kind of plume of gas that's coming out. That is the first stage from this view. That's the first stage LOX tank. It's just boiling off. So we fill saturated LOX as opposed to subcooled LOX. So
right.
Some rocket companies will fill. They pre-chill the LOX, so it's actually colder than its boiling point. So the whole time it's on the pad, it's slowly warming up.
Right.
We do the opposite. We actually fill. It's above its boiling point, and it's slowly boiling down. It's getting colder and colder as it boils.
Wait, it gets colder as it boils?
Yeah, thermodynamics.
Thermodynamics. Outside the scope of this stream,
Yes.
we'll need like a 2-hour stream to explain thermodynamics.
The magic of thermodynamics. It's
Okay.
it's getting colder the whole time. That also means that it's boiling off, so it's losing mass. So
it's kind of like evaporation, guys. When water evaporates, the leftover water cools down, right? Same happens with it. But the thing is that since in normal boiling, if you just boil water, we require energy, right? We provide heat energy, which is like by fire. So it's kind of doing that only. But since we are not supplying any fire, it's just the liquid oxygen is like that only. It does not work. It does not require any fire to be there. So it will just take away the heat energy from the system itself, which is the liquid oxygen, and then boil off. And then and hence it will slowly come down to that as he said, the temperature will decrease. Thermodynamics. They are obviously doing certain more things to it, but yeah, kind of it summarizes like that.
Where are we coming up next? We've got some payload, I think, information here. Here we go. Yeah. So this payload is actually delivering faster on-orbit capabilities for U.S. warfighters. Remember, it's a commercial payload for Lockheed Martin. It's a national security technology demonstration. What does that mean? Oh, we've got some information about it, right?
we do.
We have a little bit of information put out on social media. You may have seen that we're talking about electronically steerable antennas, I think, right?
Exactly.
The electronically steerable. You know something? The best people to tell us about the payload are the people who built it. So let's get some information directly from Lockheed Martin here, if we could.
Hi, I'm Paul Pelly, Senior Director of Global Security at Lockheed Martin Space. I'm excited for today's Firefly launch, and
Whoa, what was that? Okay.
Hi, I'm Paul Pelly, Senior Director of Global Security at Lockheed Martin Space. I'm excited for today's Firefly launch, and I want to share a little context about the unique payload we're launching into orbit. It really is all about responding to our customers' need for increased speed to mission.
I'll summarize the payload for you. That is
fully calibrated and ready to perform their missions
let's
after
listen to
initial
him
power
first.
on. Using the innovation of Lockheed Martin's Ignite team, we've self-funded and developed a unique wideband electronically steerable antenna, or ESA, for this demonstration. Our ESA is a novel scalable design using highly reliable commercial parts and is mass producible. Once we're on orbit and our satellite has completed checkout, Lockheed Martin expects to calibrate this new ESA sensor in a fraction of the time it takes to operationalize traditional on-orbit sensors. Essentially, we're going to show how we can put on-orbit capability into the hands of our warfighters faster. This demonstration is an example of Lockheed Martin's significant investment in bringing scalable ESA technology to orbit. ESAs are powerful and incredibly flexible, have no moving parts, and can generate multiple energy beams simultaneously, We believe this technology is critical to future remote sensing architectures. Lockheed Martin is excited to show what this ESA can do on orbit. Go for launch.
Well, there you go, ESA.
Yeah, so that is
Antenna.
okay.
That's the antenna that they're testing here today. It's actually launching on a Terran orbital Nebula satellite bus. So a lot of different companies, organizations coming together for the mission today. Y'all are providing the launch services. We've got a satellite bus provider. We've got the client, Lockheed Martin, with the antenna. We've got the range that helps us out as well.
And you know, guys, this satellite bus provider, it's a very booming market because there are so many universities, so many schools and other scientists also which can develop payloads, but they don't know how to, you know, manage the whole infrastructure of thrust, managing the power, and basically hosting a payload so that it becomes a satellite. It's just a scientific payload. They might not know about how to make it as a satellite. And hence there are certain startups which are coming up which are providing those services, satellite bus services. One of the example is here today, which is the Terran Orbital, and they will just you know, take your payload, but you need to obviously design it according to their specifications. But take your payload, strap onto the you know, their orbital module, and then finally it will able to deliver it to the orbit. So that's how it works. And there are certain Indian companies also in this market, and you will see them in action very soon.
There's normally months or weeks, and there's the Firefly, less than 24 hours. That's actually around 19 hours, I think, here. But a little different today, like you said, because we had the weather scrub, payload was encapsulated, it was integrated on top of the rocket, so that part was already ready.
Exactly.
And teams have been counting down today, doing the other final payload closeouts, the transport and mate to fairing. That was already done, and we've been in launch ops here, haven't we?
Right. And so, I mean, I can go into this in a lot of detail, but it's probably better to listen to people that are really experts in this.
We've got some time here, I think.
Oh, we do? Okay.
Yeah, to talk a little bit about it.
Okay,
Let's
well,
see here.
basically the way this works is that the fairing is in another building. It's called the Payload Processing Facility.
Probably the PPF.
PPF,
Yeah.
yep.
I worked it out myself.
Fairing and the payload are off the pad. They're
Right.
in another building. It's pretty nearby, but it's not on the pad.
Not just not on the rocket, but not even at the pad. It's
Right.
just a little ways away.
Right. And
Right.
so a day ahead of time or so, we encapsulate that payload.
Let's actually put it into the fairing.
Right. So we stick it on. There's a whole segment here. There's something called the PAF, the payload attachment fitting, that is right below those fairings. So you attach it to that, encapsulate with the fairings. The fairings are that kind of silver section at the very top of the rocket.
It's a little bit wider.
Yeah, bigger diameter.
Yeah.
So that whole thing is encapsulated. It's horizontal, and it rolls over to the pad under air conditioning. You can see it's fairly wet out, so we have to be really thoughtful about making sure that that payload doesn't get wet, because
You don't want rain on your satellites.
yeah, water on satellites is like, no, not allowed.
Not a lot of water
Yeah.
in space.
Yeah, so we can't allow
Okay,
any water to get on the
I have a
satellite.
question
so there's
for
very
you
specific
guys.
humidity range that we're allowed to be in. We also can't get too dry, because
Right.
then you start risking like arcing and stuff like that.
Gotcha. So you control the environment that the satellite's in.
Yes, so we have this little portable air conditioner that, you know, carts along next to the payload fairing. It rolls out to the pad. The rocket is on the pad on the strong back. It's
Right.
already mated and everything. And then we raise that payload fairing and stick it onto the end of the rocket, and then it's ready to go.
Gotcha. You made a little hand motion, like you did this number.
Yes.
Is it actually a cart that somebody's pushing?
It
or-
is. I think it actually is a cart right now.
Well, I saw them
'cause
raise the
move
payload
We
up.
move pretty slow, and then the payload fairing itself is, you know, there's a bunch of people out there. It's a
I saw cranking operations to raise the payload.
There's some cranking involved.
I think there might be a pickup truck towing things around
there's
too.
some people that are stronger in certain ways than they otherwise would be.
Because we're like, go for cranking operations.
Yep.
Anyways, so all of that has been done, not just today in the last 24 hours, but in the
So,
nominal flow for the responsive space
So
operations.
Wildflower
It's
are
24
trying to
hours
hash
to
out
not only put the payload in the
no moving parts steerable antenna. Does it use different frequencies? So basically this is again Lockheed Martin developing something for US military. So we don't have much of the information which is out in the public. So we don't have that information which you are asking for. But but it's like as the name suggests, right? Electronically steerable antenna. It's able to steer the antenna. Again, I have to research on more about it, like how does that work. Maybe they have made something like that in the past also. I haven't gone through it, but as I know, it would be kind of a simple thing. It won't be that much of a big complex thing. But again, it's a technology demonstrator mission developed by Lockheed Martin for Space Force, so there might be some complex parts also. So I can't comment much on it because again, it's classified.
Right where we want it to be. And the beauty was the excitement, right? That we had, that area was ownership, that had that ownership for the system, that's saying, we're not giving up, right? And up to the day of, it's like, it's getting tight, we can't do it. It's like, no, how can we do it?
Ultimately, the team was able to work through those. So getting the payload out there a little later than planned, hitting a few other bumps in the road, and then rotating up and launching. And what is the record time for us? That for what we look to do, it's not demonstrating the best ever. It's, are we getting incrementally better every time?
And the amazing thing was that we hit our first window on the first day, on the first minute that we attempted.
So responsive space as a whole is really kind of just taking the things that the business, I'll say the industry, has let become stagnant. That there's a concept that you have to have all these checkouts and all of this stuff that happens before you encapsulate and lift off. And for extreme high value satellites, that normally makes sense, but now the industry is lopsided where the satellites have come down in price and the launch prices have basically stayed the same, to where it all comes down to how fast you can do that last bit to give your customer a white glove service to space.
VICTUS NOX was a challenge, but we're trying to make it now as the new norm, right? Because then obviously the Department of Defense is going to be really
basically was like that. So as I told you, right, on a very short notice, they were able to deliver it to the orbit. So kudos to them, they were able to do that. And yes, Wildfire, regarding the electronically steerable antenna, it's like, you are not exactly moving the physical antenna, you are controlling those the direction of the antenna by electronically, which means you kind of do that by using multiple radiating elements that can be individually controlled so that the beam can be shifted rather than the whole antenna. So this is how it works. But again, the specifics of it and all those things are still not out in the public. And but kind of, by adjusting the phase and the amplitude of the signal, of the signal sent to each element, there can be certain small elements on the antenna, and we can control the what should I say, the phase and amplitude by using the signals, and basically we can adjust the phase and amplitude, and accordingly the beam would shift rather than physically moving the antenna itself. So kind of amazing.
Like say you have a network of satellites up and one of them has a failure, a problem. How do you replace that? Well, why don't you just leave them all up in space? You designed that satellite 5 years ago, 7 years ago. You launched it 3, 4, 5 years ago. Technology's come a little way since then. So why not have your most recent technology in the hangar on the barn and then send it to space when you need it, if you can get it done in less than 24 hours? We heard about airline-like operations for rockets, for space, right? And when I book airline tickets, I don't book them 6 months in advance. I don't book them 2 years in advance like rockets have to book their trips right now, right? Like payloads have to book their trips. I book my ticket to come out here the day before I needed to be here, and that's sort of how responsive space operations work.
Exactly. It's much quicker.
It's much quicker. All right. So coming up next, we're going to talk a little bit about something that's near and dear to your interests, the Alpha rocket itself.
Yeah. Alpha's a two-stage rocket. You can kind of see on the frame there that the first stage is basically everything below that first lower line of the ice.
Yeah, there we go, with the logo on it, the Firefly.
Yep. So that ice is where the LOX tank is. So it's like maybe 80% of the rocket itself is the first stage.
Right.
So that does most of the heavy lifting, and then the second stage is that little segment in between the silver fairing and the first stage.
Gotcha.
So it's
and
much
rockets,
smaller.
exactly.
It actually does most of the change in velocity, but it's doing most of that sideways rather than up.
Rockets.
So the first
Right.
stage is kind of getting us up,
Nice
and then
name.
the second
Out of
stage
the
is
atmosphere,
going
get a little altitude.
Right. So Alpha carries about 1,000 kilograms to low Earth orbit. So that puts us in kind of we're the largest of the small launchers.
So it's the largest of the small launchers.
It's
So a smaller payload. I mean, 1,000 kilograms is a
Yeah,
small
it's like
payload.
we're putting up like a dishwasher.
Dishwasher, couple like a refrigerator or something.
Yeah. Yes.
Nice.
Yeah, big little guy. So that first stage is run off of 4 Reaver engines.
Right.
The second stage is a single Lightning engine. Those are all designed, built, tested in-house. They're both tap-off cycle engines. So,
Okay. Tap-off cycle.
Yep, tap-off cycle. So when we talk about a cycle of an engine, what we're talking about is how the turbopump is being spun.
It's how the engine is providing power, or I guess flow, for itself, right?
Yes, exactly. So
Gotcha.
in a tap-off cycle engine, you're taking there's the combustion chamber where all the propellant is exploding continuously.
Right. In a very controlled manner.
In a very controlled manner, and it's you run that through to the turbine, and that spins the pump.
Right.
And the pump then puts more propellant into the chamber for that to then combust and keep that.
I
process going.
already
Right. So
explained you
tap-off
the
cycle.
tap-off
Latest,
cycle.
greatest technology. You trying to break any records, or why'd you choose that one?
No, tap-off cycle's actually been around for like 50 years. The sort of the follow-on actually to the Saturn V second stage was going to be a tap-off engine.
Right.
But never flew.
Hmm.
So that
Let's see here. So we were talking about the tap-off cycle. We're not trying to break any records.
right.
With the tap-off
So
cycle.
it's
or anything like
it's
that.
not. It's
He
a
handled
very
it very
simple
well.
cycle. So
Right.
there's not very many parts to this. Normally with an open cycle engine that would be similar performance.
Right.
You have to have what's called a gas generator, which is like a tiny little rocket engine, which
Sure.
is hard to make. So we have fewer parts. It's easier to produce. It's a little bit more complicated to get it started.
Yeah.
To figure out how to bootstrap that start.
Gotcha.
But
But you're going for reliability. You want something that's simple,
exactly.
fewer parts, easier to manufacture.
Exactly.
fewer parts means fewer things to break. So we're into tap off.
Gotcha. Good deal. We had a quick question from the audience, actually. We said it's about 1,000 kilograms. What's the max? Is that the maximum payload? Because it says 1,000 plus.
Well, so it's a little hard to say one number there, right? Because the
Basically what happens is in tap off and gas generator, the difference is that we have a mini turbine in gas generator. As the name suggests, you are generating a gas in a certain combustion chamber. A mini combustion chamber is there, and that gases from that combustion chamber is then fed to the turbines to rotate the turbo pumps. So that's how it works in gas generator cycle. It's kind of when it comes to open cycle engine, it's kind of on the easier side, but tap off cycle is more on the easier side. So if you'll rate the ease of making of all this rocket, it will be the tap off cycle will be coming at first, open cycle, and then the gas generator will be coming up. So in the tap off cycle, you are not basically doing any gas generation. You are whatever you are taking from the combustion chamber, getting from the combustion chamber, you are feeding it directly to the turbines, and then it will rotate the turbo pumps. So here there are few moving parts, and as I said, they are aiming for launch cadence so that they can launch on demand, right? So because of that, they want certain things, certain rocket which can be built reliably and fast, and as well as which has less moving parts. So this is how it is. Now the problem with it is that it is kind of difficult to start the engine. Why is it so? Because gas generator, it's like it's a chicken and egg problem. So you need if I talk about the gas generator, you need the gas generator to function first so that it can rotate the turbines, and hence it will rotate the turbo pumps, and hence the cycle can be obtained. But for the gas generator to work, you need the turbo pumps to supply the fuel to the gas generator, right? So how does that work? I mean, they are interconnected with each other. They both want to work together. So hence, for gas generator cycle, they have this thing called they take the help of the ground support systems, which will initially pump the fuels and oxygen so that the gas generator is able to come to its full thrust, and then finally once it is working and everything is going on, then the full engine starts working, because now the gas generator is on, the turbines will be rotating, which it in turn will rotate the turbo pumps will again feed the fuel to the gas generator, and it will work. But here in the tap off cycle we don't have a gas generator. Now how do you solve this problem? You still need that gas in the combustion chamber. Now you cannot feed directly from the, I don't know how they solved it, so this I can't say, because this is some patented technology which they are using. So but yeah, what I meant to say is the problem which they solved was this only, the starting of the engine. They have somehow figured out how to start a tap-off engines reliably, and once that was a con of it, and they have figured out to make it as, it's not a con anymore. So yeah, it works.
So operations are ongoing right now. The pad is clear. We talked about that a little bit earlier, but there's still things happening with the rocket to prepare for launch. A couple minutes ago, I think we were talking about stage 2. What are we looking at?
Yeah, so about 10 minutes ago now, the second stage LOX tank started being topped off. So basically we boiled down, we lost some mass, and now we've set up just a trickle of LOX into that to keep that at the flight level.
So it was like pre-filled, and then it emptied out a little bit, and then you started topping it back up.
Keeping it just still at some specific level. Anything that boils off, we add back in.
You have like a cool acronym for that, or it's just called topping off?
It's just called top off.
It's just top off.
Yeah, and so at second stage, you can probably see that a little bit in that plume in the top. If you've been paying really close attention, it got a little bit stronger. 10 minutes ago. That's also, it's convenient for us. This is not, because of the tank construction, these are it's really easy to get, very predictable temperatures in this. So,
because of the carbon composites.
Yes, exactly. They're basically this acts like a thermos. It's pretty unique construction. It's super lightweight.
Is it 2 walls like a thermos? Like
it is 2 walls. It's called a sandwich panel.
A sandwich panel.
There's other composite rockets out there, which is kind of the way things are going.
So if you have seen thermos, right? There also it has like this only. So we have 2 layers, and then in between we have some insulating layer, mostly thermocols and all those things. So kind of similar thing we have used here, because obviously they are now going. Let me tell you one thing. They have painted their rockets black, right, which absorbs more heat from the sun. Now they actually, if they will just don't have any layer in between, they will expose all those heat which is coming from the sun to the tanks, and it will boil off immediately. Not immediately, but it will not stay there for a longer period of time. And the calculations and all the wastage and everything will mess up. So to solve that, they needed that middle layers of insulation, so that it can block the heat coming from the outside, as well as it will block the heat which is in the inside. The whatever temperature is inside, it will stay like that only. So there will not be any communication, or should I exchange of the heat from the surroundings and all those things. Obviously, not everything is 100% insulating, so there will be some certain leaks which will happen, but it's manageable. So again, black color is not recommended, but they have, since they are using this technology, just the thermos technology, I would say. So yeah, it's fine then.
There's droplets everywhere. The speed of sound in water is different. Yep. So as that wall of sound hits that, it decoheres. It goes in all different directions. And then whatever gets back up, it also loses energy in the water.
Yep.
Whatever gets back up to the rocket is way lower energy and just doesn't
effectively mitigated. Whatever reaches the rocket is
mitigated. We're kind of pulling like a curtain in front of the rocket as it leaves the ground.
And it's not just about, it's not a solid body of water. The water is sort of in droplet format. It's spread out, and so there's think about it. There's tons of interfaces. It goes from air to a water droplet to air to a water droplet, and every time it's going through that interface, I guess you could say, it's changing the direction. It's dealing with some of the energy. It's making sure the sound isn't shaking the rocket to pieces as it goes off the pad.
Exactly.
All right. And then coming up here, where are we? 30 seconds from T minus 30 minutes. What's going to happen at T minus 30 minutes?
We should be able to see this on the stream. The second stage engine is going to start pre-chilling. So there's two, again, same way as the vent up there for the tank. There's two outlets that are coming out of the kind of the lower part of the second stage.
Right.
What we're doing there is we're pulling LOX, liquid oxygen, through the engine, and we're chilling in the LOX pump. So if you don't have your pump really cold when you try to start your engine,
right.
When it starts to spin, instead of pulling LOX through it,
liquid
yeah,
LOX.
instead of pulling that liquid through it, it will just flash that into gas, and it'll just sit there spinning.
It's like cavitate?
It's cavitated.
It literally cavitates. So when we talk about engine pre-chill, we're chilling the engine down to a proper operating temperature, so you're not surprising it or trying to get it to operate in a temperature it's not supposed to be.
Yeah, exactly. A lot of the sort of secret sauce of rocket engine operation is that you just make sure that always the conditions that the engine is getting are exactly what you thought you were going to get. So then you can test it and make sure it's going to work.
Gotcha. All right. And again, folks, we may be able to see a little bit of that. Again, the venting that you see on the screen and stuff like that, that's all intentional. Loxygen. I'm not supposed to say it's LOX. Loxygen. Liquid oxygen or LOX. Alpha rocket, Firefly's Alpha rocket here. Just got a little bit of a range weather update in my ear, and they just told me that the range is green, or the weather is green.
Weather
currently.
is green.
Yeah,
that's what we
so
want.
we on 2 days ago we scrubbed for weather. That was a compounding set of factors. About the worst weather you can have in Vandenberg.
Yep. I was surprised. I was told it was beautiful in California, and I show up and I'm like, it's raining. What's happening?
we had both very thick cloud cover. We had lightning coming towards the pad,
right?
And we had high upper level winds. So it was just like boom, boom, boom. Everything is terrible. We still fought through a ton of that, and in fact, also the weather was terrible the next day as well. So we were fighting through that for operations on the ground, just getting ready for today.
Even we were out there dealing with cameras, and we were getting poured on Thursday there. So, folks, remember we've talked about a couple different things. Weather is currently green, it sounds like. How do we get the weather for the launch pad? We don't just go to our weather app on our phone and say, what are the upper level winds? It's actually Vandenberg Space Launch Delta 30 that supports the West Coast launch activities here for Department of Defense, NASA, and commercial missions like this one here. They've been doing a ton of work to enable these responsive space missions. We've got a little bit of information here from Colonel Mark Shoemaker, who is the commander of Vandenberg Space Force Base. So let's go ahead and listen into what he has to say.
All right.
This is a special time of year for Guardians.
Space Force Base. We're celebrating the fourth. What I was saying something. Yeah. So in the previous launch was scrubbed due to weather, as he said. It was like around 20% go for the launch when the launch window. Before at T-2 hours or something, it was 20% go for the launch, and because of that, I thought I would not stream it, because again, if I'll stream it, I'll have to cancel my stream because it will get scrubbed. Unfortunately, that only happened. So this time also, the problem with Vandenberg is we don't get space weather update. Basically, weather on that 45th, what should I say, weather squadron, something like that is there, right? Which maintains the probability of violating weather conditions and all those things. We don't have it for Vandenberg. So I did not know if today will be the launch which will happen, because people in the stream, in the official stream, they were saying that there will be some issues with the weather because they live like 50 minutes away from the California, and it's not good out there. But weather is green today, and which is awesome, which is what we want.
Space capabilities empower the world, our nation, and our entire joint force. And our commercial partners deliver many of these capabilities, playing a vital role in achieving our nation's strategic objectives in space.
Delta
and so it's vital
Heavy.
that we responsibly support our spaceport partners to assure resilient U.S. Space Force spaceport capabilities to launch and deploy national security missions on short notice. We take great pride in our U.S. Space Force in the two-space part of the mission, and we must continue to be more responsive, remove obstacles at every opportunity, shift launches earlier, approve launch attempts on very short notice, as we demonstrated in support of our U.S. Space Force VICTUS NOX launch on September 14th this year.
And all of this is to enable simultaneous launch operations and countdowns, delivering the spaceport of the future that the nation needs. It's my pleasure to lead the Space Launch Delta 30 team who makes launches from Vandenberg possible.
Hey, Sai
We will
Datta,
continue
yes.
to foster a culture
After
of
a
innovation.
very, very long time. You can see all this, right? I was preparing for all this setup and everything. Again, I have to do certain more things so that it will be a proper setup and we can stream it and enjoy it regularly.
You know, I talk about this a lot. It's not just the launch provider. It's not just the payload customer. There's so many different teams, including the Space Force Delta 30 out here at Vandenberg, that support these launch operations. It's always good to see what goes on, especially as we get into these higher cadences. We have a lot more rockets to launch and how they support that mission. We had another question from the audience come through here, actually. I don't know the answer to this. We talked about there's some ice forming on the outside of the rocket as the atmosphere sort of freezes on the outside. Does Firefly have to account or calculate that? When launching?
We kind of did an early calculation just looking at it the first time we got out here, because in Texas we basically didn't have any ice.
Okay.
We got out here and there was a brief worry, but if you are able to go out there and touch that ice is it's very, very thin. It's like a thin dusting of snow.
Don't do that, by the way.
Don't do that. So that it's not very much to begin with. But then the other part is that in the launch, there's a lot of aero heating on the outside. So as you're going so fast that the air just gets hot.
It warms up.
Yeah, it's frictional heating with the vehicle. So the rocket is hot as it's flying away.
Gotcha.
And almost all of that ice melts away during the first stage burn. And first stage mass
is the bigger stage.
It'll be like mass of the first stage, and so that doesn't contribute as much to payload loss as the second stage mass would. When the second stage is burning, when that would matter, it already has
It's
no
already
ice on
melted
it.
off. It's
Yeah.
like the payload fraction of, or the mass fraction of the ice.
Yes.
Is low, or it's
Mass
it's
fraction
low
of the
because
ice.
the
Nice.
payload or the booster mass is high when the ice is on there.
Yes.
And it's gone by the time you get to the
That's a
second
good way to think about it.
I sort of stumbled through that, but I hope you all got the point. Coming up, where are we
So
at here?
here
Less
you
than
go, guys.
25
There
minutes,
was the
23
answer
and a half
to
minutes
it.
about
So
here.
basically, that ice is not that much. Again, that would depend on rocket to rockets. If you remember Space Shuttle, those ice crystals were not good and have caused issues, right, in past. So because Space Shuttles, tanks were there for a very long time. I'm not sure about the architecture about all those tanks, how they were designed. Okay. But in this case, as I said, right, they are using some layer in between, insulation layer in between. So because of that, there is not much of ice which can be found. Maybe not much of what should I say, energy, right? Cold, or yeah, heat energy. No, it will be cold only. So there is not. It's not too much colder. So because of that, it's unable to deposit on the surface. So yeah, there you have it. And maybe if they are launching from Florida, it also depends on the weather conditions, to be honest. So, but as he said, it just gets melted when it goes up in the sky. So
engine startup, we have about maybe a second where we look at the engines and everything on the stage, and it's an automatic check that is going through. Computer looks at everything and says, okay, it's healthy. We let go of the clamps, and then we immediately start accelerating upwards.
We get first motion, and then we'll see a trajectory that looks a little bit like this here. There's that stage 1 ignition, T-1 is 2 seconds, liftoff T0, and then we go into Mach 1, Max Q. Tell us about those.
Right, so Mach 1, that's when we're supersonic. Max Q is the point where the density is dropping and the velocity is going up, and the combination of those two things means that at some point there's a maximum point where you're like crushing the rocket.
Yeah,
with
the maximum dynamic pressure.
With aerodynamic pressure.
Based on the the density of the atmosphere and everything else.
And those are the two most sort of difficult control regimes that the rocket has to pass through. Supersonic, when you pass through the sound barrier, you have to
deal with those forces.
Yes.
Like that's where the forces are. I mean, you go through a little bump when you pass through the
your
sound
control
barrier.
scheme has to change.
Yeah.
So both of those are hard, and then Max Q is just hard because there's a lot of forces.
Yep, and we saw MECO there, main engine cutoff that's going to be happening.
okay, yeah, I know about that logo war which is going on Twitter. So yeah,
15 seconds later, the fairings will pop off.
let's see what happens. I think we have already.
And then we have 5 minutes burn
It's
time,
the
and
power of Indian population.
All
on display
So that
there,
is what
right?
we'll expect after liftoff here. I think in just a couple minutes, we're actually going to come up on a mission control call out. We're going to try to pipe that into y'all, but we don't know exactly when it's going to happen. So if we're in the middle of something or saying something and we need to go to mission control, just expect us to zip up and listen in on the go no go poll that's coming up here shortly. So we're talking about these launches, and we had the main engine cut off, we had the SECO, but there was a SECO 1 and a SECO 2.
Right. So SECO 1 is the first time the engine shuts off on the second stage, and we've used almost all of our propellant at that point on the second stage. So it's really lightweight.
Right.
And then there is about 45 minutes usually of coast period
FSW, go.
because we've
GSW,
done
Okay,
a
we have the
GNC, go.
Here's the go.
Prop,
Go.
fluids,
Go.
structures,
Go.
AVI,
Go.
FTS, go. GC, go. VC,
Go.
Payload,
Go.
PMM,
Go.
Elbow,
Go.
FISPO,
Go.
IFCO,
Go.
OSM,
Go.
ROC, MA,
Go.
CE,
Go for terminal count.
LD,
LD is go.
LDs
LDA.
go. Range is
go
fine,
for
and
launch.
we have the launch decision authorities clearance also. So everything looks
That's
fine.
what we wanted to hear.
There you
That
go.
is what we wanted to hear.
That was just straight. That was smooth.
Yep, super smooth. That's great news.
Just straight down
You
the pole.
can
You saw we
see
had a
Everyone is happy right
greens
now.
there.
Finally, we'll
Flight
able to
4,
see this rocket
go
launch.
for launch.
There
It
are
looks like actually we
okay.
got
Let me
some-
summarize
I think
this
that's
mission.
actually back in Texas, that
And
area.
so there
Texas,
we
somebody
have
cheering.
this
Looks like
Alpha
saw some
rocket
hands
in
the
front
air.
of you. This has
Still
capability
have
of
some time. We're
around
under
1
20
tons to
minutes
low Earth
now,
orbit
folks,
of
but you just
around
heard the
300
go-no
kilograms.
call, and
On
looks
first
like
stage, it has
everything is
4
currently
Reaver
green
engines,
as we keep
which is
marching
going
towards
to
that T0
which are
that's
running on
coming
RP1
up
and
here.
locks as
Let's
its
see
fuel
here. What do we-
and runs on
Is that like an
tap-off
exciting
cycle, which
time?
I've
Like, is
already
that like a-
explained.
oh, it's really
The
happening
second
now.
stage is
Yes,
one
the time
lightning
between
engine,
saying
70
go and
kilonewtons
then
of thrust it will
rocket
produce,
hitting the ground
and also
is
it runs on
20
tap-off
minutes, but
cycle.
it
For the
feels
second
like
stage, though,
20
there is
seconds.
one
It's
unique
18
thing,
and a
which
half
is
minutes now,
that
actually. It's
the exhaust
very
which
fast.
goes
It
out
just- time just feels like it
is used to
evaporates here.
cool
So-
become one of
the
plots
extension of the second stage
All I see is go,
nozzle.
go, go, go.
So that is something
All
cool.
right,
I would
so
like
folks,
to
if you're
know
just
more about
joining
it. I
us,
did
you're
not
watching
find much
Firefly Aerospace's
information
official broadcast. We're coming
how
up
that
on
works,
flight
but yeah,
4 here. This is
that's
Alpha
how it
rocket
is.
launching
And talking
a
about the
Payload 4
payload, we
Lockheed
have
Martin.
the
And in fact,
payload from
we've
the
actually got a
Lockheed
couple words
Martin,
coming up from
and
Lockheed.
it's like
Let's go
the
ahead and
electronically
listen in on
steerable
this
antenna,
to hear
which
what they have
is
to say.
nothing but you don't have to move the antenna physically to know to change the direction of the antenna. You do it electronically by changing there are certain radiating elements which you can control, and then after, if you can control that, you can control the beam also. So it's a technological demonstration mission, and we are hoping for it to be success. And also this is the direct competitor of PSLV. It's kind of made and targeting that market only because the payload capacity is almost similar, not too still PSLV is higher, but still it is aiming for that market, the ride share payloads, and even the launch cadence of this will be higher than PSLV, and there won't be any this huge stack of paperwork which people have to do with the in the case of PSLV. So yeah, let's see how it works, how it will deliver.
You cannot go it alone. We share a lot of similarities with early entrants like Firefly, and we are proud to work with them and other emerging providers because it takes a variety of innovations, capabilities, and people to ensure we are all successful. Together, we will ensure a resilient launch environment and assure access to space for all important missions. Thank you to the entire team supporting this Fly the Lightning launch. We're looking forward to the ride. Let's go for launch.
Folks, things are going to start happening really quickly here.
Yeah, obviously the cost per kg is not comparable to ISRO's. It's take around $15 million per launch. But again, it comes down to launch cadence. Do you want the? Most of the time, what happens is these the satellites, whatever goes up, are funded by investors. From the universities also. Universities have a good chunk of money. If you don't know, they have a good chunk of money. So the customer itself, the people who have made the satellite, they are not paying directly for it, right? So in that case, they prefer the launch cadence. and how soon they can go up there and finish their mission. So in that case, they will go here and there will be customers for PSLV also, the people who don't want to spend much money and they can wait. But again, there will be a shift, and finally after this will start becoming more and more reliable, operational. Cost will also come down. It will become more competitive. So let's see how that pans out. But again, the PSLV itself is the answer for this is the SSLVs, the ISRO's SSLV, which is supposed to be rapid in development and is able to provide with all those, the cons of PSLV is taken care by SSLV in case of launch cadence, the maintenance, the readiness and all those things. But obviously it's not that much of a it does not have that much of payload capacity. So rideshare missions, can it support, like in PSLV, the PSLV launched around 110 satellites, 104 satellites, that was the record, right? So it won't be able to launch that much, but still it will be able to launch more frequently.
Less than 15 minutes away. The time just evaporates as we get this close in the count. Important things just happened while we were looking at that video. I think we're into the terminal. You know what it is.
Yeah, so we should be in what's called terminal count.
Shri Sai Datta, I mean, if you will consider Indian government universities, IITs, NITs and all those things, right? They have money. They have money. I'm telling you that. They just don't want to spend it. They think that they will get everything from I mean, they want to do it cheaply, but they do have money for all those things. And we have the skirt cam. That's how it is. The skirt cam, you can see the engine, those insulations and all.
That is blowing through these first stage LOX pumps.
So
we time this. It basically takes 15 minutes to chill in those pumps, so that's when terminal count starts.
Okay.
Hey, by the way, on the engine cams real quick, when we were we have a lot of cameras for the broadcast, and we were choosing cameras, we saw the engine cam, we're like, we have to have the engine cam. And some folks were like, nobody wants the engine cam? No, that doesn't show much. Chat, do you want to see the engine cam? Let us know in the chat if you are interested in engine bell shot. There we go. Thank you. During rocket operations. So you can see the vapors there, like Miles said.
You can also see that flicker of it's kind of changing color. That's jumping liquid or gas. So as we're running through that line, that bleed line, there's heat going to that. So most of it is gas, but as it gets more and more chilled in, you'll see that it'll be more and more liquid.
It gets dark, like it's a darker white line, I guess, right?
Denser, yeah.
Yeah, denser. That's the right word. Nice.
Kind of looks like
all right, so we're continuing to go forward here. 12 minutes and 40 seconds around that. What do we have coming up next? Some ground side preparations, I think.
Yeah, so we have
now.
The kind of last setting for TTEB and spin start. Both of those systems are kind of inherently dangerous to both the rocket and the
wildflower. So skirts are basically the insulation covering only. So it's like those pipes are and everything's are there, right? If you have seen you will be able to relate it more by the SpaceX Starship launch. You saw the fire in the engine, right? If you remember, it happened because there is less, what should I say, pressure on those engine bells when the engine is operating, because high velocity particle, high velocity fuel is coming out of the engine bell. Because of that, low pressure area is created above the engine bell. And sometimes, and if you have seen that on the SpaceX launches also, the Falcon 9 launches, that the plume itself goes up sometimes, right? This happens because there's a low pressure area there. And there might be certain components, electrical or something, which can get damaged for the Firefly thing if the flame goes up. And hence they have this insulation covering so that the fire from the engines cannot go up.
They can vector in more than one direction.
Right. So the Reaver engines only have a single axis thrust vector control.
They just move in one direction.
Each engine only has one axis. So you have pitch engines and yaw engines, which is kind of a common scheme in like Russian and Ukrainian rockets, but not so common in American rockets.
Okay.
But it's simpler. There's fewer parts. You don't have as many things to deal with. You don't have as many things that can break.
Yep.
So that's kind of typical Firefly direction.
Like each engine just hinges on one axis, and I imagine you have 4 engines. you probably have 2 pitch engines and 2 yaw engines?
Yep, and then they can all move together to roll the rocket.
Ah, gotcha. And they're probably at 90 degrees from each other, like the pitches and the yaws, and they makes sense. There's the engines again. I
So
didn't
yes,
see the
I
TVC
also
wiggle,
talk
but you know
about
something you should probably
this
check.
single axis gimbal, which how they manage it. So there will be two engines which will move in X direction, and the other 2 engines which will move in Y direction. Okay, so this will happen, and they'll do, from the software perspective, they'll control these engines, their directions, so that they can achieve all the things: pitch, roll, and yaw control by only one axis gimbal. In comparison to Starship or Falcon 9, which have multi-axis gimbal, this only has one axis gimbal. One axis gimbal means only it can move, the one of the engine can move only one direction.
Why do you wait so long? Like, why don't you put it to full pressure before, like earlier?
So and you'll kind of see this in all of these things, that there's a lot of stuff that's happening in these last 15 minutes, and it's all set up in time so that we don't put cycles on components that we don't want to cycle.
Ah.
So everything has some qualified number of cycles, and we want to make sure that we don't sort of erroneously put a cycle on something when we didn't need to, because if we're going to find a problem with something else that is, more critical, then we don't want to accidentally damage something
Gotcha.
just by using it.
So every time you send it up to flight pressures, I guess, right? You use up one of those cycles.
Yeah, it's called a lolly.
A lolly?
Lolly.
Yeah.
Lolly.
You're putting a lolly on the tank.
Putting a lolly on the tank, all right? Burning one of the cycles that you have there, and you don't want to do that too many times. You want to make sure everything else is good to go before you put a lolly on.
Yeah,
I don't know how to use that as a verb.
That's how you do it. Before you put a lolly on the tank, you don't want to do that. So the fuel tank actually has it'll get pressed up first. The LOX tank doesn't get pressed up until T-3 minutes. And part of that is that you can see where we're blowing that LOX out.
Yeah.
When we press that LOX tank up, you'll see this will pick up a lot. So you're going to be using more LOX through that bleed system, and you don't want to use too much LOX. So we wait until the very end.
Oh,
gotcha.
Nice.
And then after that, we're going to get into, after the fuel pre-press, I guess, begins. It takes some time to do that, right? We might get into stage 2, I think, huh?
Yeah, and I don't think we're going to be able to see this. I don't think we have a camera in the vehicle on this feed. We actually do have a camera in the vehicle that operators can see. And they're going to do the same thing as we did on the first stage, where we're going to look at the engine and see it move. It moves a lot less in the second stage.
They
the
are
first stage
struggling, but I hope
it's
they are able
in
to
the interstage, so it doesn't have a lot of room.
deliver.
So not visible from the outside of the rocket.
Yeah, but it'll do a little
very
little
soon.
wiggle,
Let's see.
We'll just verify everything's good there, and just that's our last check of that system.
Gotcha. We got a big bunch of fog there all of a sudden, it looks like.
So right now only we can see so much of these things, these lines coming up. But he said these are basically the liquid oxygen lines, and this will pick up at around T-3 minutes, because when the LOX tanks will be pressed, so more pressure will be there. And yeah, okay. Just listen to
this. So there's Slick 2 over there at Vandenberg. That's the spreading T plus 30 seconds. 40 seconds. Down there in Los Angeles, you might look out over the ocean. Not sure if the clouds are going to be a problem out there for you. Up to San Francisco, you might be able to look south. Again, fighting the weather here. Not sure. If you can see it from Las Vegas, let us know on social media, please. Phoenix, good luck. But look out there today. If you're able to walk outside, you might get a chance.
View area, guys. So if you live nearby, you can go and check the rocket, but you can see the weather is not looking good. I hope they are able to lift off.
Minus a couple, T-minus 7-ish minutes, I think.
6 minutes, yeah.
Yeah, there we go. Just crossed under T-minus.
TVC
wiggles. It actually says stage 2 TVC wiggles on the screen. Nice. I like it. Also coming up here in 40 seconds or so, transitioning to internal power.
Right. So all day today, we've kept the batteries at charge, but we're not actually drawing power from the batteries on the vehicle. So we're just letting them sit there. They're doing their own thing, and we're feeding power to the vehicle from the ground. And that we're now switching over. We're switching over now to have the power draw from the vehicle and feed to directly.
What do you think,
still,
guys?
topping
will
it
it
off,
lift off today? Seeing the weather, it might violate the cumulus cloud and lightning conditions. Not sure. But cloudiness is the issue. You might not be able to see the rocket if you live like far away, Las Vegas, Phoenix and all those things. So, yeah.
We'll get the collar arms open.
Yeah, at the top of the rocket on the strong back, you can see.
There you go. That's the view.
So those are going to open, and we
There
keep
you
them
go.
closed normally. Oh, there you go.
There you go. Good timing.
And then the strong back will retract a little bit after that once we're sure that the collar arms have done what they're supposed to do.
They are definitely retracting. It's almost like this is a carefully choreographed ballet of rocket machinery.
Almost. Yeah. So those pull away. The strong back's gonna retract. We don't do that early because the wind allowable on the rocket is much higher if you have that attached.
Ah, look at that. There it goes. And it's got a little slack in the umbilicals there. Umbilicals, right?
Yep, those are
This
umbilicals.
is the bottom view.
We call them catenaries for some reason. Catenaries, the curve of when you're under gravity.
Wow, look
and
at that
somehow
camera
that
view.
just stuck.
Well, they're
But
curving a little bit less under gravity
industry
now.
term would be umbilicals.
All right.
You can see that there's these
Uh-oh.
it's getting away, but it's not actually, nothing's tight yet. There is some maybe elastic pieces there,
Just a little, not
but
droop
most
to it.
anything
It's slack.
that's hard has a droop to it because the rocket is actually what pulls that off. The movement of the rocket will pull those QDs off.
Ah, so it's not something that pushes out or anything. Like the rocket starts to move and it pulls those QDs out.
There's a wire
Quick
rope that's gonna yank on those QDs, and it'll open a latch and things will fall off.
Gotcha. Folks, it's 4 minutes and 30 seconds now. We're still
And we
marching
have
towards
the trench
T0.
cam
Haven't seen
also
any holes
here.
in the counter or anything like that.
No,
We got that
going good.
super smooth go, no-go poll. We do have one last go, no-go poll that's coming up here around T-minus 2 minutes. It may happen a little early. It may happen a little
Oh,
late.
look at
so
that.
if we're talking and we jump to that, we want to listen in on that final commit. But a lot of things still happening here. We saw the strongback retract. Look, this camera is even different now because the strongback has retracted. You can even see the ice on the side of it.
It's also, you can see it's one side that you get ice on.
Yep.
Because it's the same temperature, but there's just more airflow going over the other side.
Yep.
I wonder if that's the windward side or the leeward side.
It's the leeward
Leeward
side.
It's the
side.
leeward side where the wind is not blowing
Yep.
that freezes the ice. No kidding. And we're going to be getting into things like fuel bleed and that sort of stuff here, but now under 4 minutes from launch as we watch all sort of different views of the rockets. We do expect to have some pad audio coming up here as well. And for the last probably 90 seconds or so, we're just going to let you all soak in the sounds of the pad and hopefully the ignition and liftoff here. 3.5 minutes. Still counting down. This is go time, isn't it, Miles?
Yeah, yes. This is the nail biter.
How you doing? Can we put a heart rate monitor on you and like graph it on the screen?
I'm climbing
T-minus
up the
3
walls.
minutes
I don't
from
have
the
plots in
launch.
front of me.
Everything is
Normally
looking
have screens
good.
to look at.
Range is good, green. The weather is hopefully supporting.
All right. Well, the count
Still worried
continues to
about
happen as we
those
begin to
clouds.
cross over
Let's
the
hope
T-minus
that is not a
3-minute
party
mark.
spoiler for us today.
Here again, this is Firefly's Flight 4. It is Fly the Lightning, a commercial mission for Lockheed Martin. About 1 minute away from that final commit to launch, where the launch conductor is going to ask for the go, no-go. So we are definitely going to listen in on that. We got some clouds up there today. I see a little bit of blue, but hopefully we get some visibility of the rocket as it goes. Can it go through the clouds?
Oh, yeah. There's a certain amount of thickness of clouds that you can't get through because of both ice buildup and tribo electrification.
I was hoping we would get a chance to say that.
You'll charge the rocket up, which is bad for the avionics, but there's some amount of clouds you can get through, no trouble.
Good deal. So, folks, let's go ahead and do this. Let's listen in on the final commit. We'll do our best to be
Final
quiet.
commit for launch, Chief Engineer. Alpha is ready. Send it.
Oh,
Director.
yeah.
LD's go for Flight 4.
Rock.
Yeah. And range
You're
is
going for
also
launch.
green. That's it, right? Yeah.
Folks,
and we are going,
T-minus
guys.
2 minutes. That's what you wanted to hear. The final commit to launch. 3 goes from the Chief Engineer, the Launch Director, and the Range Operations Coordinator. Quick reminder for folks watching, we do expect that we'll have on-board video, hopefully, but we will be intentionally cutting that feed after SECO 1 at the request of the customer.
After
We're
SECO
coming up
1.
on
Remember
90
that
seconds,
too.
a minute and a half for Firefly's Flight
90
4.
seconds.
You know something? I think we're going to listen into the pad and the command net, and we'll just say, go Alpha Flight 4, fly the Lightning.
T-minus 1 minute 20 seconds remaining, guys, and we have been given final go for the launch. I am very excited. If you are, just hit that like button and send your best wishes to this rocket. Hopefully this will deliver today. And T-minus 1 minute 5 seconds to the launch. Everything is looking
60
good.
seconds.
Those 4 river engines is supposed to light up very soon, and I'm really excited for this. There you go, guys. It's happening. It's happening. Okay, nice. Again,
45
to
seconds.
quickly sum up, this is a classified mission, kind of. So we don't have that CCO2. Oh, you can see those, you know, as now they have, since the LOX tank have been pressed, we can see more of those
Technology
fumes
alarms.
coming off. T minus 30 seconds
seconds.
remaining.
CD1 vehicle has transitioned to autonomous mode.
And T
20
minus
seconds.
20, 19, 18,
Stage 1
17,
motion,
16,
15,
15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5,
5, 4,
3.
2, 1.
Ignition. It just never bores me. Never ever, it will never bore me. It's always amazing, a good sight to see, and finally those 4 Reaver engines working as expected. Look at that go, man. Those clouds, just hopefully if the weather was clear, we could have seen more of them, but you can see that clouds, and I think it's gone. We need to go to the next camera.
Vehicle supersonic.
Vehicle is supersonic, it's working, it's just the screen which has hanged. So they need to switch over to the next camera. It's on the, and this is inside the, inside the payload fairing. And here you can see we have the rockets. It has completed the max Q, so structural, it is fine on the structural side. It's coming up for the main engine cutoff. It's looking fine. It's going great. We'll soon see those plume to expand rapidly. We can see that happening right now. This happens because it goes in the vacuum, and there the air pressure is not that much to compress the plumes which is coming out of the rocket. And here you can see it's expanding. It will expand much more than this. So don't worry about it. We have seen all those Falcon 9 launches, right? We know how does that work. So here you can see those shock
See the
diamonds.
plumes start to expand there.
Yeah. And this is the second stage. You can see, you can actually see from here how those exhaust gases cool the second stage.
That's the lightning engine, isn't it there?
Yep.
Okay, what is this? What was that? What is this? Okay, nothing to worry about. I think that was the and we have Miko.
That's Miko.
Eco.
Stage separation and the second engine startup. There you go, guys. It has happened. Whoa.
Stage separation.
Look at that.
Stage
Finally
2
done.
ignition. Power
It's
nominal.
working as expected. Here you can see the
Nice.
those exhaust pipe which
Seriously,
is
see the
fed
booster
into
there.
the nozzle to
second
cool
stage
it up.
continuing on.
Yeah, we should see the fairings in just a second here.
Fairing jettison has happened, I guess. No, not yet. Yeah, official confirmation now, not according to the timeline. And we can see
Bada
the
boom.
space, the Earth,
That was
Mother
the-
Earth. Wow, always.
Payload for
Just
separation?
look at that view.
Separation.
Oh
Just
my
let them
God.
say it. Look at that view.
We can see those fairings go away. No. So literally, guys, the exhaust gases of the
Now
combustion
this is a longer
chamber.
burn now, right?
Yeah,
Kind
much
of.
longer.
Yeah, combustion chamber is going to cool the exhaust nozzle. You can see how cool those gases are before they are fully ignited and all those things. So some of the energy is taken away by the moving of those turbines. So there is something, and after that we have those gases fed to the
trackers.
nozzle so that it
Through
can
the
cool
clouds
it
on
down.
occasion. It's easier to see through the clouds from up here.
Yeah, yes, it is. And we're going to start seeing, you can see a little bit, that second stage engine nozzle extension is going to start glowing, which is normal.
Okay.
It's radiatively cooled because there's nothing around, right? It's vacuum.
Because the black body radiation coming off it started to glow red.
And so you have to deliberately make sure that nozzle extension has high emissivity, so it'll cool itself naturally.
It'll radiate off a lot of that energy.
Mm-hmm.
You can see how it's moving, right? The Earth is going, and yes, flat earthers, look at that curvature. Look at that curvature. It's spherical. Earth is spherical, not flat. So yes, so right now the second stage is burning, so it's produces
T plus 5 minutes, everything is nominal.
Sun in the background there.
Everything is nominal. So yeah, 70 kilonewtons of thrust it produces. RP1 and locks as its fuel it runs, and it's the Lightning 1 engine where it runs on tap-off cycle. So relatively simpler engine, but again now this is where something, you know, how they are able to manage the in-flight ignition of the second stage with the tap-off engine. That is something which is remarkable, which they have achieved. And because of that issue, you know, the starting of the engine issue with the tap-off cycle, it might not have the reignition capability. They might develop in future, but right now it does not have that because it's kind of very difficult to reignite this engine. Ignition itself is difficult. Reignition would be 10 times difficult. So yeah, here you can see the satellite.
T plus 6 minutes.
After the SECO 1, you will, I mean, we won't be able to see those views. So that, you know, obviously it's a secretive satellite, classified one. They don't want people to know about its orbit as such.
Those onboard cameras keep sending us pixels. We'll take
why
them.
do they even...
I think we should have it all the way through to SECO.
Okay. Some of the ice particles.
So.
Yeah. And a quick reminder here, folks, at SECO 1, we do intentionally plan to cut the feeds from the vehicle at the request of the customer. We'll still be here with updates for you.
Okay. SECO 1 is coming up. Right now everything is looking nominal only.
T plus 7 minutes.
So their FLTA002 or 001, I don't remember. The one of the mission got failed. That was the initial mission, and I still remember that mission was actually getting streamed by an everyday astronaut. And today they have partnered with NASA Spaceflight to provide those production capabilities so that they can host a live stream. So that is nice. And they are, but before that only, after that they were able to achieve the orbit, and now they are able to do it on a regular basis. So the reliability of the vehicle is increasing. So that is nice. That's
a little piece of ice on occasion go past.
Mm-hmm. Not all of it melts off. There's always a little bit that hangs out.
Stuck in little nooks and crannies. And
if you watch the last video as well, same thing happened.
Copy.
Earth is always filmed by the wide angle lens. Still, okay. But still, the movement is too much, I guess. The lateral movement. I hope it's able to... it's intentional. And if it's not intentional, it's able to correct. And we have SECO. There you go.
Nominal transfer orbit achieved.
Normal.
There you have it.
Transfer orbit achieved.
We got a transfer orbit achieved. It sounded like the call out there was.
That's pretty good.
That's pretty good.
Pretty happy about that.
That's pretty good, he says. Folks, you saw it. Flight 4 flew the Lightning. I guess you would say flew the Lightning.
Flew the Lightning.
We had liftoff from Vandenberg. Here's back at Texas. I think that second camera we have there, some clapping going on.
Expected LOS
but let's talk about what's next.
I'm
going to be quiet every time I hear Mission Control. We're still coasting. We've made it to SECO 1.
We're coasting.
Mission's not done.
We're in orbit now. So we're in an elliptical orbit right now. And then if you think about kind of we enter that at the lowest point in the orbit.
Right.
So now we have to coast along to the highest point in that
You're kind
orbit.
of coasting uphill right now, actually.
Yes. And so once we get to that furthest point, then we'll light the engine again, and that'll circularize us. So then we'll be in a big circular orbit, and so that's the useful orbit.
Gotcha. So what happened is we took a lot of chemical energy that was stored in the fuel of the rocket. We turned that into kinetic energy, and we pushed the rocket forward, and now that's sort of coasting uphill, and it's turning it back into potential energy.
Yes.
Height above the surface of the Earth.
Physics lessons
in
the live stream.
The velocity is decreasing now as it increases its altitude.
Yep.
And the total energy, it's a little bit of atmospheric drag maybe way up there, but the total energy is about the same. It's just trading height for speed right now.
Right. And so then at the top, that burn is super short. It's like I joke that it's a cough. Like it just, and it stops. So it comes up to power, drops almost instantly. It's like it's a little triangle of thrust.
Just real quick.
And then we'll reorient the rocket, the stage with the RCS, so that we have these little nitrogen cold gas thrusters.
Right.
They're also active during the burns because you have to have roll control.
So keep it on its
because you only have one
trajectory.
engine, so there's nothing to keep you from spinning.
Ah, right.
And so those will reorient the stage, and then we'll deploy that payload, and then mission complete.
Good deal. So, folks, a reminder, the mission is still ongoing. We are in this coast phase, about 45 minutes long. We won't be on the entire time here. But for the most recent updates, make sure you head over to Firefly's social media channels. Over on X, there it is, at @Firefly_space. And that is going to be the best, fastest way to get updates on the ongoing mission for Flight 04 here. Do it right now. If you do, let's get a clickable link into chat. Maybe in chat, tell us you went over there and followed Firefly_space on X. Now, that's not all for Firefly. What's Firefly got coming up next here?
Well, we got a lot more Alpha flights. Flight 5 is the NASA Venture Class Launch Services program. So
VCLS?
VCLS. Yep, so we're launching a payload for them. That's happening in early 2024. It's also going to be a responsive launch, so it'll follow the same paradigm where we encapsulate and send the whole thing out to the pad and
minimize the time there.
Yeah, verticate, and leave.
He said it. It's a real word. Like you could use that in English class now.
I don't think
Scrabble.
I don't think
good.
it's a real word.
It counts in Scrabble. Point him to this webcast. That's a real word.
So we have we also have now our new orbital space tug Elytra that is going to be flying on an Alpha. So it's kind of purpose designed to fly in Alphas. You could fly it on something else, but it's purpose designed for Alpha.
Oh, there you go.
That is for the NRO, and that is also responsive space operation. It's kind of different in that instead of it just being that we can launch whenever, we can now put up that OTV, that Elytra, and it's floating around, and you can command it to. It has a bunch of payloads on it, and then you say, okay, I want this one to go now, so it'll deploy something whenever.
Gotcha. Is that from Minecraft?
No.
It's not actually. As if I haven't asked him that question before.
Elytra are the on a Firefly or any Beetle. It's the like there are two sets of wings. It's the hard shell of the wings.
The hard shell of the wings.
Yeah.
Gotcha. So a scientific term there for that mission. Also coming up, Blue Ghost.
Yeah. So the first Blue Ghost mission is happening in 2024. We're flying to Mare Crisium, which is the if you look at the moon in the northern hemisphere, this is kind of hard to describe, but as it's rising, if you look at it, there's all these kind of black spots on it. Those are called Maria. The little spot in the top right corner is Mare Crisium. So we're landing on the edge of Mare Crisium.
Gotcha. Whoa. And remember, if you're watching from Australia and looking at the moon's going to be upside down.
Yeah.
A lot of people haven't thought of that. Like you're literally standing.
That's what Indian media would portray it, right?
That's part of NASA CLIPS. It's commercial lunar payload services. It's a bunch of instruments measuring radiation. There's some technology demonstrators on there, test sample collections. We're done with the structure of that, so we're now integrating that final lander to get sent up.
So not just renders, there's actual structure, there's hardware that's been built.
Yep. And then the second Blue Ghost mission is also in work. That's a little bit bigger.
Gotcha. All right. Other upcoming missions. Folks, there's a lot of stuff going on with Firefly. Head over to their website, fireflyspace.com/missions. Mods, if you could put a clickable link into chat so folks can go and check that out. There's a ton of things that y'all are going on, including something we mentioned at the very beginning of the broadcast,
Yeah,
MLV.
My rocket.
Your rocket.
Yeah, so MLV is
MLV,
our bigger rocket. We just had the first engine hot fire.
Now, wait, time out. That was green.
That was green.
Is that cool?
That's cool. That's T-Teb. T-Teb burns green. It's hard to see it green when on a video camera, but in stills, it shows up green.
It shows up as green.
So we did that first Miranda engine hot fire. We have been building up like crazy. That's a
Carbon
picture of the
fiber.
AFP.
Look at that.
Automated fiber?
Automated fiber placement machine. So what that does, it's basically like a 3D printer for composites. Except that the benefit of this is that because you're laying down a single fiber at a time, you can put them in whatever direction you want.
You almost change the grain of the. It's not grain really, but you know what I mean.
But it means that you can set those fibers to be in the direction that takes the most load, like optimally. So instead of 3D printing metal, where you kind of have to add extra material, and it is actually a little bit weaker, in AFP you're making less material and it's stronger. So it's lighter weight and stronger.
Nice.
And also it's easier to make. It's way faster.
And that's what you're using. I mean, that machine is, there was a picture of the machine there. That's going to be used on MLV, the medium launch vehicle.
Yes, it'll also be used on Alpha.
Okay.
So that'll switch us from building barrels in weeks to building barrels in days.
No kidding.
Nice.
Pretty cool.
You have a lot of barrels out there, like a yard full of barrels?
We have got a lot of barrels out there. If you come and visit, it's Barrel City.
Barrel City. A lot of people don't understand it's not just about making one rocket. It's about learning the process to make the rocket.
Yes.
So you practice that. You have extra hardware sitting
Honestly,
around,
the harder part is making a bunch of rockets.
Yeah, that's what Elon Musk summarized in one of those EDA's interview. The process of making rockets, how hard it is and how crucial it is to streamline that process.
Of Flight 4. Make sure you head over to social at @Firefly_space to get the latest updates. How are we doing on time here? We've been talking about a lot of different stuff. I don't really want to end the stream, but I know that we have a specific amount of time where we're supposed to end the stream. We're getting there, but not quite yet. Please make sure you follow along on Firefly Space. Now, you have on a cool shirt.
I do have on a cool shirt.
Don't try to show the back. We'll fall off the chair. We tried it in a hurry. We're fall off the chair.
Yeah, I'll beef it.
So if you're interested in getting a mission patch for the launch that's happened today, or any of the other stuff that what else can they get?
Patches.
Patches.
And
there's patches. Wait, hang on. I got those.
Comically oversized guitar picks.
What is that? Hang on. That's a guitar pick?
Yeah, this is a guitar pick.
It looks like a miniature mission patch almost. I love the logo on this thing.
We usually make challenge coins, and we made these instead.
You made comically large. Have you ever ordered something from online and you're like, oh, that looks good, and then you get it and it's either way too big or way too small? This guitar pick is for a very large guitar. The mission patches as well. Also, I think there's merch like T-shirts. Look at that. Fly the lightning. If you don't have somebody to toss you a T-shirt behind the camera, head over to... That actually worked pretty well.
That did work
I'm surprised I caught that. Head over to fireflymerch.com. Let's see if we can't get the clickable link in the chat as well. Oh, geez. We also... we were getting ready for the holiday spirit today. And with our comically large guitar picks, we put together a little Christmas tree. Did we have we had a Christmas tree out on the pad. If y'all saw on social media this morning, there were some shots of a Christmas tree that was making the rounds around the pad while the red team was closing out things. There's a couple shots on social of a Christmas tree. I feel like I need to hold this thing up or anything. We taped guitar picks to the Christmas tree so that we could have it here to get into the holiday spirit. But folks, what'd you think of the launch today? You're watching over here. You could have had a couple different places you were watching that. Maybe you were over on social. Maybe you were watching on Firefly's official channel. Maybe you were watching on the NASA Spaceflight channel. We were providing live stream broadcast services for Firefly today. Let us know in the comments what you thought of the coverage, and let us know where you're watching from. One of the coolest things for me, Miles, is we get to share this sort of stuff with folks all over the world. It's not just people that are here able to, go to the Cape or to Vandenberg or wherever to see the launch. But by watching the live streams like this, y'all can be a part of this experience no matter where you are. So tell us in chat real quick. A lot of times I would try to speed read the names of places that they're from. But I don't have the capacity to do that right now. But just let us know where you're watching from all over the world. What else do we think is going on here? Miles is like good.
I'm pretty happy. I'm a little, anytime this happens, you're a little punch drunk for, the next couple of hours.
Yeah. Almost like rocket shell shocked a little bit, like adrenaline.
Yeah. We still need that second stage burn, the second burn, but
the mission is ongoing.
Yeah.
No declaration of celebration or anything like that.
No, not yet.
We've gotten a long way. We've gotten a lot of good data for sure from the mission that's been happening so far. But again, social media is going to be the right place to get those updates. Firefly_space, even after the stream ends here. So let's see. All right. I think that's going to bring us on to the end of the broadcast here. I think we were planning on having some relays. I do believe that we have replays to show you here. Actually, that's why we were talking about where'd you watch from and stuff, because we needed just a minute more to get the relays better. Stall. We've got some angles that you didn't see on the live stream that we're going to share with you in these replays. Are they like playing music to play us off here? I'm not sure. They might be.
For the Oscars.
Hey, anyways, folks, thank you so much for joining us today. We put the tree on the ground, but happy holidays. Whichever way you were watching or however else you were sharing this experience with us, we do appreciate you. Make sure you follow the channels that you're on, especially Firefly's official channels over on YouTube. They're going to be continuing to release some cool stuff for you. Miles, appreciate the time today. Thank you so much for hanging out and watching the rocket launch.
Thanks for having me.
Providing a bunch of good information as well. I think there's a couple facts in there that I didn't know. And any stream where I learned something is a great stream. Also, folks, my name is John Galloway. I'm with NSF. You don't have to go home. Well, you should stay here and watch the replays because they're coming up next. Thank you all so much for watching. Happy holidays, and we'll see you nerds later.
Great. Okay, so this is engine cam. And we have T-tab ignition and the final ignition. Look at that. It took some time to come to full thrust. That was amazing. Okay, this is one of the other cams. So you can see here how those lines are here. There you can see, the feed lines get removed, and there is a certain rotation also which happens if you notice that. And there you go, just a little bit of rotation, just a little bit. And the FLTA004 is successful. Yeah, exactly. And yes, the Starship, the SpaceX is operates on next level. They are already testing the Flight 3, right? And it's amazing to see how that one looks like. We'll see whether it will be able to deliver it. So hopefully it will be on orbital launch this time. So yeah. Okay, we have few scientists, the booster 10, all those things obviously same quality stream from Sky Vikram 1. I get my see the problem with the right now the Indian launchers, right? They will, the private launchers I will focus on the publicity. They require that public factor, right? So hopefully we will get to see certain good views on the launch. But talking about the launch, the this thing, what's onboard camera views, that might not be possible initially. It can be, it cannot be, but because those are not mission critical things, those are just there for views for us. So it would be amazing to see if they are able to do that. So congratulations to them. And yeah, finally, so we do have this thing, guys. Let me open that up. Where is it? What was that? Do we have it? No. The link for, and yes, Aditya L1 nears to the L1 point. Here you can see, guys. So it's almost there to the L1, hopefully. So talking about this thing, right? The moving from the Earth's orbit to the Sun's orbit and then finally to the L1. Required certain maneuvers which ISRO was not aware of. So here actually they took some help from ESA's already established software which allowed them to do this. Obviously they made some changes in it, they might have improved it also, don't know the specifics of it, but yeah, that was required so that they were able to do all this. Okay, where is that? Yeah, here you go. We are winning on this part, so ISRO will win here. So next part will be this, guys. So whosoever is watching stream, I think we are going to compete with NASA's worm logo, right? This one. To be honest, my favorite is kind of NASA's worm, so we'll have to see. I can't see the, okay, let me vote for this. Yeah, 72.6%. Let's see who wins finally. Finals will be between ISRO's logo and the NASA's worm logo. So just go and I think after 1 hour we'll get to, or maybe tomorrow, I'm not sure, we'll get to know about this. I'll retweet it also so that you all can vote for ISRO if you like it. I'm not telling you that since you are Indian, so you should vote for ISRO. If you like the logo, then you can do that. Okay, nice. This is amazing. I think here you can see, right, the plume actually just reverts from this triangle to this triangle. I think this is happening because of the RVAC engines which comes into play. I'm not sure. So yeah, the RVAC engines, when it ignites, it interacts with the plume which is coming. So basically what happens, I think is happening here is we have the atmospheric engines, right, Raptor engines on this kind of side, and the RVAC engines on the other side. So when they ignite, they basically, here also the fluid, the gases are nothing but fluid, right? They will be able to interact with each other and form a pattern. So when the RVAC engines ignite, the plumes from the normal engines and the vacuum optimized engines, they interact with each other, and hence you see this pattern which almost changes, which is amazing to see, kind of, this view is amazing. गद्दारी नहीं कर रहा भाई. That's why I said, na, if you like that, then just do it. So okay, I think SpaceX also is doing that crew return mission, or what is it? Let me check that. Yep, splashdown of Dragon confirmed. So this is also done. Resupply, cargo resupply for that. Okay, so guys, next launch will be from hopefully will be the Falcon Heavy OTV 7 mission, which I will be doing it, so you guys can join me for that. It will hopefully it will happen on December 29th, which is on Friday, and we shall be able to see the launch that happens. So yeah guys, thank you so much for joining in. I think that should be it. And if you are new here, consider subscribing to the channel. We do the live streams, and now guys, since the setup is almost ready, I'll do something about this background. I hope you're liking this whatever this is, right? I'll try to make it much more smoother, much more convenient for you, so that this also looks nice. And now I'll also increase the video frequency. Also, KSP2 has been dropped. The Force Science update is dropped, and I'm planning to make certain videos on it. So look out for that. And yeah, thank you so much for tuning in. EDA का क्या हुआ? Everyday astronauts can't reveal right now. So we are doing something. That's what you want to know. That's what you should know. That's it. Okay, so thank you so much for tuning in, guys. I hope you liked this stream. If you did, give it a thumbs up, and consider subscribing if you haven't. Until then, this is Priyanshu Roila. You just saw Rocket Gyan. Stay safe, stay healthy, and bye-bye.